Hello, welcome back to Blender Sushi Live Noding. The other day we looked at sphere chalk points inside mesh node, and I know there's a bit of interestingness with that node, but I will have to investigate that node again. But today I will use animation nodes and see how animation nodes kind of do the same thing with the animation nodes BVH algorithm. So let's quickly start animation node. I will be using the default torus, and yeah, just gonna use this one because animation nodes doesn't have a torus generator yet. So I'm just gonna be using this torus, and then I bring it into animation nodes and see how we can kind of ask animation nodes to see which points is actually inside the volume of this torus and which one is outside. Okay, so I will start with a distribute matrices, and I'm gonna use the viewer to show you the result. There is actually 3D viewer inside animation nodes, so we can actually look at how things being arranged before we use it for our instancing, for example. So that's really handy. For what we are doing, we want to use grid, and this is the default grid. It's 2D, but we can make it 3-dimensional. So the grid of animation nodes start from 0, 0, 0 plane here. Maybe we need to push our torus up. Okay, so basically we want to have like a bunch of points, and we want to ask animation nodes, okay, can you find the points that's actually inside the volume of this torus? Let me save this first. Okay, let's try. I'll make this like 10 by 10 by 10. So we actually have 1,000 points here, and I can make this smaller. Bring the torus down. Okay, let's see. I know there's this node is inside volume for animation nodes, and this guy is expecting BVH3, some kind of construct. So I will need to construct the BVH3, and the BVH3 is actually the polygon mesh data. If I'm not wrong, we can just source the objects, which is our torus. So plug into this guy, and for the points, this is going to be our distribute matrices. For the matrices, so I can't just plug these matrices into this guy because this one is expecting points. So I need to use decompose matrix. So from this transformation matrix, I'm just going to get the translations, plug into this guy, and the output is actually list of booleans. If we check it using a viewer, so it's a false, 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 and there should be like it's a length of 1,000, so there's 1,000 points. So now we want to use the mask list. So this is the boolean goes in there, and the list should be coming from this guy, translations. And hopefully, if I'm doing this correctly, the new points should be inside the torus. Yeah, and seems to be working. You see all the points, the voxel grid, I mean the 3D grid that we generated using distribute matrices is now shown inside the torus. Let's make this bigger. So now that we have these vector points, we can do some neat things. For example, like let's do some quick instancing. Let's instance some monkey head, for example. Let's use Suzanne. Just grab Suzanne, and we're just gonna copy everything. This list is a number is a list of vectors points that's inside of the torus. I can actually hide the torus for now, and so this guy can goes in there. It will tell this object instancer how many total of Susan heads you want to create. So this one, the total list length goes in there, and as a result, we can use the object transform output, turn on the locations, pipe in the location data, and then the Susan head data, and we should have Susan head being arranged to our 3D grids that's inside the volume of the torus. So yeah, that's actually pretty much it that I want to show you. Maybe we can make this a little bit better with Susan. So this is the original Susan head. I think we need to scale it a little bit, and then plug this in there. It should update this guy. I need to maybe select this guy and tap U, reset source data. So now the Susan head is smaller. We still see all these lines, so I need to tap U and then hide the relationship lines. Okay, if you feel a bit of feel challenged, you can actually modify this vector list data. We don't need to care what's happening at the front anymore. We just know that there's a bunch of points inside the torus, and we want to animate those points. We can use delay fall off and then vector offset. And I'm pretty sure it's a matter of just playing around with this. Like so, maybe Susan head, we just drag it up or something. So now let's animate it. See, we can do the opposite. So yeah, so that's the whole setup right there. It's pretty simple, but you know, this is just like the basics. You can definitely change it to make this even more interesting. Durations maybe 5, delay 3, make the animations longer, display only render matcap. So there you go. That's you can actually this is like a linearly, so this motion is very linear at the moment, but you can make it more interesting, like if you use the interpolation, for example. Maybe I like this back because it's kind of overshoot. You see now Susan head is kind of overshooting down and then it gets into the position. So that's kind of neat. And what else? You can also kind of randomize it further with the rotations and scaling. I found this is like similar to, there is one art installations. It's just like a waterfall. There's water coming down from the top, from the ceiling, coming down, and whenever it comes down like that, it will display some kind of letters or logo. This is kind of similar, very, very similar kind of effects. In fact, with a slight tweak, maybe we can kind of simulate that that kind of art. Yeah, delay fall off is not very interesting, but you can use like a wiggle fall off, for example. Plug this in there, plug the time into evolutions. So let's see. So this one is gonna continuously wiggling, but you can see, you get the idea. Basically, we started with just a torus, and then we check. We start with torus, and then we use this distribute matrices to generate like a 3D grid, and then we are using this BVH3 and these nodes inside the volume to find the points inside the volume of the torus. And then after we mask the points inside the torus, we are instancing some monkey head inside that points. So yeah, it's I guess that's pretty interesting. If you feel challenged, there's also you can do it like this. Try generating like a kind of like a voxel kind of look, like a Minecraft kind of look. Remesh modifier is kind of doing that, but it's only doing it on the outside, only on the surface. But if you are using, for example, animation nodes or straight chalk, you can generate like a cube blocks for every voxelations, and then you can later animate every voxel. Maybe that's something I will do that for the next live noding. That's it for this video. Let me know what you think. Any comments, question, suggestion, let me know, and I will see you in the next video. Thank you. Bye.